So in this example, we're going to check the convergence of this series from 1 to infinity of 1 over the 7th root of k to the third plus 9. Now, for this, I am going to actually use the limit comparison test, and I'm going to use that with the p series 1 over k to the 3/7. Now I'm using this p series to compare because I know with the p series when it diverges and when it converges. And in this case, because the 3/7 is less than 1, we know that it diverges. So I'm going to compare the series that we're trying to find out about to this series here, our p series, using the limit comparison test. Now, when you use the limit comparison test, you need to take this expression here and divide it by the expression that you're comparing it with, and then take the limit as your variable goes to infinity. In this case, we're using k's. Now, I skipped the division part and I just went to flipping and multiplying to save us a little time. So here is my expression from this series. And when I divide by 1 over k to the 3/7, that's the same as flipping and multiplying by k to the 3/7 over 1. So now when I take the limit as k goes to infinity, this is going to approach 1. Now, according to the limit comparison test, if you get some value other than 0 here, then the series that you're comparing and the series that you're comparing it to, they either both diverge or both converge. Now, because I know that this diverges, then I know that both of them diverge, which means this series is going to diverge. Now, for the second part here, it's asking if the alternating series is going to converge absolutely, converge conditionally, or diverge. So when I look at the series here, it's the same series that we used up here with the addition of making it alternating signs. Now, because I have alternating signs here, I'm going to use alternating series test. And the alternating series test tells us if this expression decreases without the negatives, if just this decreases for each term as k gets bigger and bigger, this gets smaller and smaller, that's the first property that needs to hold true. And then the second property that needs to hold true is that this part, the part without the negative, if that approaches 0 as k approaches infinity, then we would say that this converges. The alternating, this one here, let me show you. This one here, this would converge. Okay, so these both hold true. So we can say by the alternating series test that this series converges. This one here that we were checking. Now, I can't say that it converges absolutely because when I remove this negative here and I look at it just with absolute value, so I'm looking at positive 1 over the 7th root of k to the third plus 9, we got that this diverged. So this series is going to converge conditionally, not absolutely. Now, if this series here converged, then I could say that this converged absolutely, because the positives, when I add up all the positive values of these terms, and they converge, then that would be that it converges absolutely. But because it only converges when you have the negatives in here, then it only converges conditionally. So hopefully that helps.